All right, we're going to fill this out together. We would have gone through it together in class. And this is just a handy study guide so that you can really think about what is going on at each type of plate boundary. These are the three plates I really want you to know about: Continental Convergent, an Oceanic Continental Convergent, and a Diverging plate. We'll start with the Continental Convergent, and this is where two plates are coming together. So it's really hard to see on here, but we have our two arrows coming together, and they rise upward to form a mountain. Underneath them, the convection currents are going together. Notice how we have the arrows on either side of the current going together because they're driving the plates on top of them closer together. The feature that is formed is a mountain, and that is because the crust is of equal density. They don't sink, so they rise up and create a mountain. And we would know that on our evidence map because we would see brown, purple, white, and we would see that higher elevation. And on either side of it, it would be surrounded by land or continental crust. In addition, you can think about a car crash happening where two cars are colliding. Rather than cars, though, we have two giant slabs of rock, right? Our tectonic plates are made of our crust, and it's our lithosphere here. That's going to create earthquakes. And so we would see on our earthquake map evidence of earthquakes happening in regions where mountains are being created. It would be rare to see volcanoes. It's not like these are creating a lot of volcanoes. So just know that if you found a continental convergent mountain range being created, land would be on either side because you'd have two continents colliding into each other, and that you would experience earthquakes. The next type of plate boundary we talked about is Oceanic Continental Convergent. The key here is you have an oceanic plate colliding with a continental plate. Both plates are going toward each other, and so the convection current cell underneath it, you actually have your oldest ocean plate here, so that's rock that is cooling and sinking and going back down deeper into our mantle. And on the other side, you have continental plate. Again, that rock might be cooling and sinking, but it's pulling both of these plates toward each other. When that happens, I'm missing my key word here, trench, you have a deep ocean trench that forms because that continental plate is getting stuck on the oceanic plate as it sinks, and it starts to form a deep ocean trench. You would know that because you would see pink in your ocean if you look on your elevation map to show that it's really deep. And right next to it, you might either see light blue, signifying that it's a more shallow part of the ocean, or you might see continental crust. In addition, when that oceanic plate sinks underneath the continental crust, it is going to start to melt and create heat and pressure, and eventually you're going to have a volcano form. So right next to your trench, you will see volcanoes. And because that plate is going so deep into our mantle, you will see deep earthquakes in our lithosphere, and you would see that by the green and the blue dots on your seismology map. Finally, the last plate boundary that we talked about is called a divergent plate boundary. That's where you have two plates that are going away from each other. So draw your two plates going away from each other. The convection current is showing less dense rock that's rising up, and as it hits each plate, it pulls each plate apart. And what happens is magma is going to come in through here. So not only are we going to have a mid-ocean ridge being created because the plates are being pushed away, we would know that because on our elevation map, we're going to see light blue to signify a higher elevation. In addition, and I forgot to add this, we're going to see new ocean floor. We can tell it's new ocean floor because it is going to appear red on our geochronology map. In this area, we will have some shallow earthquakes happening, and you might see some small volcanoes, and we would know that by the presence of a few volcanoes on volcanology map. This here is really helpful resource. What I want you to do is actually draw each plate, what direction it's moving, whether it's moving together or apart. Draw the convection cycle underneath each plate to show that how it is pulling the plates, and the direction that the current is moving must match the direction that the plates are moving. Make sure you know what feature is formed for each of these plate boundary types and how you would recognize that feature. So how would you know it's mountains on a map? How would you know that you have earthquakes or a deep ocean trench? This is study guide. This is essentially a study guide you're creating so that you can look back on here and know exactly what type of plate boundary you have at a particular location based on the evidence that you are seeing on your data maps.